So students, in today's lecture we will discuss about the types of CNC machines. CNC machines can be classified according to their working, according to the number of axes, according to the number of control loops, and many other ways are also there on which we can classify the CNC machines. So the CNC machines we can classify in this lecture according to the functions of CNC machine, and then according to the motion of the CNC machine. Okay, and next classification will be number of axes of the CNC machine, and the fourth classification is the according to the control loop of the CNC machine. So the CNC machining is a manufacturing process that we have discussed in the previous lecture, that programmed software to direct the motions. The classifications of CNC machines indicates the types of equipment and works they can do. However, many types of CNC machines are there. These content will introduce each kind of CNC tool. You can find the difference between these different types of CNC tool. The CNC stands for the computer numerical control. So the CNC machine tool is automatic machine tool equipped with program control system, and that can achieve the purpose of complex, precise, small batch and multiple CNC parts processing and production. CNC machining parts and processing and production. There are many types of CNC machines which can be classified into their different categories, like the function of the CNC machine and the motion of the CNC machine. Like the function of CNC machine, motion of the CNC machine, number of axes of CNC machine, and control loop of the CNC machine. Further, according to the functions, that CNC machines can be classified like the CNC milling machines. Okay, CNC lathe machine. That lathe machine we can also name it as CNC turning. Or next subclassification is the CNC drilling machine. Then after CNC drilling machine, next classification is plasma cutters, CNC plasma cutters or CNC plasma cutting machine. Then CNC grinders. CNC grinders are used to grind the different objects, to grind the different workpiece, while the plasma cutters are used to cut the sheets. Drilling machines are used to create the drills. Turning machines are used to create the cylindrical parts, while the milling machines are used to create these planar parts. Next one is the CNC punching and bending machines, sheet metal punching and bending machines. That machines are used. You can use such machines to create the sheet metal objects like boxes, panels, almirahs. Okay. Now, according to the motion, this CNC machine we can classify it like point-to-point motion. Okay, and the contouring motion. So in point-to-point motion, that CNC machine will move, the CNC spindle will move from one point to other point. Okay, now next point like CNC drilling in the case of CNC drilling. Contouring in the case of the CNC contouring, that will perform the continuous motion. That head or the tool will perform the continuous motion. That is the CNC contouring. Number of axes, 2 axis CNC machine. Okay, 2.5 axis of CNC machine, 3 axis CNC machine, 4 axis CNC machine, and next more versatile and multi-purpose machine is 5 axis machine. And according to the control loop, this CNC can be classified and categorized like open loop control systems, CNC machines that will have the open loop control system, and CNC machines that will have the closed loop control system. In this lecture, we will see in detail about the different types of the CNC machines. So first one is the CNC milling machines. CNC milling machines are used to create shapes like slots, okay, holes, notches, grooves, pockets, and especially faces, and perform the machining process of manufacturing CNC milling parts. The rotary cutting tools on the mill to remove the material from the stationary workpiece. So in this case, this workpiece, this milling cutter will rotate. Here you can observe this is the head where these milling cutters can mount using this automatic tool changers or the magazine in many cases. So when this tool that when you will mount a milling cutter there, then this milling cutter will remove the material from the stationary workpiece. Workpiece will stationary on the work table. That work table will move in X and Y direction, while this head will move in the Z direction. Here it is the Z direction. Okay, so that is the CNC milling machine that is basically used to create the planar objects. Okay, planar objects that you can use to create the slots, like such slots. Such slots you can create. Okay, such slots you can create using the CNC milling machine. Holes, you can also create holes in workpiece. Notches, different types of notches can also be created. Grooves and pockets can also be created like this. Such pockets can also be created in the workpiece. So that is the milling machine that is basically used to create the planar features on any workpiece. Next one is the CNC turning machine or CNC lathe machine. CNC lathe is used to manufacture the cylindrical object, okay, cylindrical objects, and perform the process to producing CNC turning parts. A cutting tool will shape the workpiece while the material block is turning rapidly on the spindle. So here you can observe a spindle, and here it is the chuck. This you have to mount the workpiece on this chuck, then this chuck will rotate, and hence this workpiece will also rotate. And here using a single point cutting tool, here in this image you can observe a drill bit, but this can also be changed. If you this will hold the single point cutting tool, then you can easily perform the turning operation. You can create groove also in this cylindrical object, but in this case you can also create a hole in this object using this using this drill bit. Okay, so this is holding a drill bit, and you can create a hole in this object. So here it is the tool post, or I can say the tool holder. This tool holder will move in this direction, okay, in this direction and this direction. So this will have only the 2 axes. So this is basically 2 axis CNC machine. Okay, this is not the 3 axis CNC machine, but while in this case of the milling machine, that was the 3 axis milling machine. Okay, so CNC turning machine is basically used to create the manufacture the cylindrical parts, to manufacture cylindrical parts. Okay. Next one is the CNC drilling machine. CNC drilling machine used to drill hole in workpiece, that is used to create or drill holes in workpiece. Okay, like here you can observe, this is the table, you can mount the workpiece over there, and this is the head will hold, this tool holder will hold the drill bit. This drill bit will create the holes in this workpiece. So this is the basically the CNC drilling machine. So CNC drilling machine is used to create the holes in the workpiece. The tool can locate the position for drilling quickly and accurately the holes. Sophisticated drilling machines can also be perform reaming, counter boring and tapping holes. That are the different operations like reaming, counter boring, and tapping. That operations can also be performed using the sophisticated drill machines. Okay, so this drill machine basically perform the point to point operations. Like this head will move from one point, this position, then it will change the position and locate the another hole, then another. So this will be the point to point operation. Okay, but in previous case there was the continuous operation. Now next is the plasma cutter, CNC plasma cutter. CNC plasma cutter machine is basically cut the different types of the geometries on the plates or sheets. Okay, it will be the plate or sheet. So the thickness, according to the thickness of object, we can classify it in the two categories like plate and sheets. So on the basis of the intensity of this plasma, energy of this plasma, you can cut the different types of geometry on the plates or sheets. Okay, plasma cutter machine is a machine that carries a plasma torch. Here it is the plasma torch. Okay, this plasma torch, here you can observe, this is the plasma torch and this is cutting the different geometries on the sheet. Okay, so CNC plasma cutters, a machine carries a plasma torch which is for cutting metals, involves cutting through electrically conductive materials by an accelerated jet of hot plasma. So that will have an accelerated jet of hot plasma. So the key points for the plasma cutter machine is it carries a plasma torch. That is the tool basically, plasma torch, not T, and which is for cutting the metal, involves cutting through the electrically conductive material that can also be processed using these CNC plasma cutters, and this will cut the material by an accelerated jet of hot plasma. Accelerated jet of hot plasma. Okay, so this is about the CNC plasma cutters. Next one is the CNC grinding machine. CNC grinders or CNC grinding machine, a machine used a rotary wheel to abrade the material by grinding or grating into the desired shapes. It is easier to program than milling machine and lathe. So the programming of CNC grinder is quite easier than the milling machine and CNC milling and CNC lathe. That will have the rotary wheel, that is the basically grinder. Rotary grinding wheel. Okay, rotary grinding wheel. That rotary grinding wheel will generally rotate at higher RPM. Okay, that will have higher RPM, and that will grind, that will remove the material from the workpiece. And the programming of CNC grinding is easier than the CNC milling and turning. And next is the CNC sheet metal punching and bending machine. CNC sheet metal punching and bending machines are basically used to create the panels, like panels you can observe here in machine itself. Such panels you can create with the CNC sheet metal punching, because such panels are basically fabricated using these sheet metals fabrications. And in case of sheet metal fabrications, you have to bend the sheet, you have to punch the sheet, you have to join that sheet. So for the bending and punching, you can use the CNC sheet metal punching and bending machine. Here in this image, you can observe the CNC punching machine of Amada. Amada is the well-known manufacturer of such CNC machines, CNC punching machines. So when we talk about the CNC punching, then this punching machine will create the different types of holes in the sheet. Okay, like if you want to create the different such type of holes in any sheet, then you can use the CNC sheet metal punching. While in case of the bending machine, that bending machine is used to bend the sheet like this. If you want to bend the sheet, like here, if this is your sheet, then this you can bend the sheet in this way. Okay, using the CNC sheet metal bending machine. Here it is the bend die, that die, and here it is the die, it is the punch. This die and punch combination will use to bend the CNC that bend the sheets. Okay, now next classification of the CNC machine is according to the motion. So when we talk about the motion, then we can classify the CNC machine. I can say we can divide into point-to-point system and contouring system. First is the point-to-point motion. In case of the point-to-point motion of the CNC machine, the material and tool are placed at certain fixed relative positions, at which they retaining until the cutter finishes the process and retracts. This type of equipment including drilling, boring and tapping machines, and each axis of the machine driven separately by lead screws at a different speed. Okay, so each basically the first that will position these controllers will position the tool at the appropriate location, then it will perform the cutting operation. Okay, this type of equipment including drilling, boring and tapping machines. Next one is this next one subclassification is the contouring system. The contouring system CNC machines tool cut the material following a contour or a path, like such contour. It will follow such contour or a path. Okay, or so it works in a continuous path. This type of equipment including lathes, mills, and routing machines. Okay, routing machine, lathes and mill machines we can consider. It is also known as continuous path system. The CNC contouring is also known as continuous path system. The positioning and machining are both performed along the controlled path. This type of equipment including lathes, milling and routing machines. Okay, so this is the CNC contouring machine. The CNC sheet metal punching machine is basically the point to point machine, point to point type of machine. Okay, now according to the number of axes of CNC machine, we can classify it into the 2-axis machine. 2-axis machines having the motion along only the 2 axes. Example, CNC lathe machine. Okay, like here it is the only x axis and here it is the z axis. In case of the lathe machine, that tool will have only the motion only along the 2 axes. Okay, so CNC machine gives access to only 2 axes. Like the lathe machine, the tool moves in the 2 direction, x and z. So that machines are basically known as the 2-axis CNC machines. Now 2.5-axis CNC machines. It is also a 3-axis system, but movement is not in 3 dimension. The x and y axis move to the position first, and then the 3rd axis starts to work, such as drilling and taping machines. So first this machine will position the tool. Okay, the machine will position the tool at the appropriate place, then that will start the work, or I can say then after positioning, that machine will start the material removal operation. Okay, that cannot perform the simultaneous positioning. Okay, so you have to understand this point, that it will first locate the tool at the appropriate place, then it will start the material removal operation. Next one is the 3-axis machines. 3-axis CNC machines. The 3 axes are basically x, y and z. So the such machines can move simultaneously in 3 dimensions. Okay, it is the most widely used and versatile machine that can achieve high accuracy and precision, and this can also be used for the automatic interactive operations, milling slots, drilling holes and cutting sharp edges. So in case of the CNC 3-axis CNC machines, the axes are moved simultaneously and that are versatile machines, as we have seen previously, like the CNC milling machine. This one was basically this 3-axis CNC machine. This is the 3-axis machine. Okay, that can move simultaneously along the x, y and z direction. Okay, that can move simultaneously in x, y and z direction. CNC milling machines we can consider in this classification. The different operations like milling slots, gear cutting, okay, and drilling holes, and cutting sharp edges. Okay, so that are few types of example of the operations which you can perform using the 3-axis CNC machine. Next one is the 4-axis CNC machine. The 3-axis machine with one more rotation. Okay, so the 4-axis CNC machine, the 3 is basically the 3-axis machine with one more rotation on A axis or B axis. The common example is vertical machine or horizontal machine. In the case of 4-axis machining, Milling is performed on the additional axis, while the operation on the XYZ is the same as 3-axis system, and the rotation on the A and B axis is around the x-axis. So that will basically rotate these around the x-axis. Okay, around the axis that we can say the A-axis or the B-axis, A-axis and B-axis. So that is basically the 4-axis CNC machine. Now come to the 5-axis CNC machine. The 5-axis CNC machine, the 3-axis machine is basically the 3-axis machine with extra rotation along the 2 direction. That directions are Y and Z direction on A axis and B axis. The rotations are respectively given by the bed and spindle movement. Spindle movement basically is the pivot point. 5-axis machines are advanced CNC machines, and its multi-dimensional rotation and tool movement allows the creation of precise and intricate parts due to the improved access to undercuts and deep pockets. Unparalleled finish and speed often used for the high level applications like aerospace part, artificial bones, titanium pieces, oil and gas machines parts, military products and many more. So that is the basically 5-axis CNC machines where you can create the complicated parts like artificial bones, because that will allow the undercuts, the motion of the tool in undercuts areas or access the undercuts and deep holes. So in such a way you can create the parts having the complicated geometries. Now according to the loop control loop, the CNC machines can be categorized open loop CNC and closed loop CNC. In the open loop system, the signals are sent to the servo motor by the controller, but movements and final position of the work table are not checked for accuracy. But in contrast, the closed loop system is equipped with various transducers, sensors and counters that accurately measure the position of the work table through the feedback control, and position of the work table is compared against the signal which you have sent, which the controller have sent. The table movement terminate when the proper coordinates are reached. So that is basically the closed loop control system. So the open loop control system is like we can show the open loop control system using a block diagram. Like here it is the motor, stepper, motor. Here it is some gearbox. Okay, and here it is like lead screw. This lead screw is having some work table. Here it is the work table. It is like your lead screw. It is the work table. Okay, this is the work table movement, and here it is the pulse train. Pulse train will feed to the stepper motor. Stepper motor will rotate, supply the mechanical work to the gearbox. This gearbox will reduce or increase the RPM or power to the lead screw, and then lead screw is basically used to move this work table in different directions. But here you cannot. You can observe any kind of feedback system. So this is basically the open loop control system. Okay, And open loop CNC machines refers to the system where the communication between the controller system and the motor is one way. So that is basically one way communication. Okay, the process for an open loop system is simple, and the CNC software creates the information with necessary steps and direction signals based on the user's purpose. The computer relays this information to the controller, okay, which then energize the motor, and no feedback. Open loop machines are used stepper motors basically. Come to the closed loop machines. Closed loop machines we can show using a block diagram. We can draw the block diagram, like here it is the comparator. DC servo motor, DC servo motor, gearbox, and here it is the lead screw, work table. Okay, this will measure the position. So here it should have some position sensor. Here it will have a position sensor. Okay, so this is your position sensor. This position sensor will measure the position of the work table, and that will send the feedback signal to the comparator. Here it is the input. Okay, here it is the feedback signal. Okay, here it is the gearbox, where it is the gearbox. So this closed loop system is basically use the feedback system to measure the position of the work table and do the respective corrections if required in the position of the work table. So closed loop CNC machine has a feedback system to monitor the output of the motors, also able to correct errors in position, velocity and acceleration of the table and the tool. The feedback can be returned to the CNC controller or computer. The former type that was the open loop control system is more common. The system with feedback fed into the signal generator or computer usually exists in high-end machines. So that is basically closed loop CNC machines. So in this lecture we have discussed about the different types of machines. We have discussed about the classification of the CNC machines. We have seen the different types of CNC machines. Now in next lecture we will discuss about the different types of the motions, different types of operations of the CNC machines. Thank you.